So my talk is on doing toolchains declaratively, which is very powerful with Nix. So the main thing is this. Toolchains essentially allow for being able to target different platforms that are compiling code between systems. One of the problems with toolchains has been that on a lot of distributions they live in random places like opt or just in USR local. With Nix, we're able to put them in a very specific location, which is very powerful. And one of the other problems is toolchains can only target one platform until you have to compile it for another platform, like GCC. If you want to target RISC-V and you're on x86, you have to recompile GCC entirely, which can be very difficult if you don't have the hardware for it. With Nix, we can easily do this and distribute it between multiple systems using remote builders and various other features. So the more of Nix way of doing things is splitting toolchains into their base components. So this would be having a derivation specifically for your C compiler, runtime libraries, your C++ implementation, bin tools, and all that. Currently, LOVM and Nix packages does this, but we're working on this with GCC right now. Another powerful thing is being able to have multiple versions of a compiler, because some code might like only certain versions of a compiler, and being able to change versions of a compiler dynamically is very useful. So one of the current problems we have with compilers in Nix package right now is GCC is very monolithic. Essentially what that means is GCC will build all components inside of one derivation, which takes a lot of time, so you're not able to parallelize it that well. It's also not multi-target. What this essentially means is GCC only targets your current target. Like if you have GCC targeting ARM, you can't tell it to specify, or you can't specify to do x86, or you can't specify to do RISC-V. You need to do an entirely new build, which could be another 30 minutes, or on slower hardware, a few hours of just compiling GCC. And one of the problems we also have in Nix packages is cross compilations are heavy. One of the ways this is a problem is we essentially instantiate an entirely new instance of Nix packages. So let's say if like Nix packages takes about 4 gigs of RAM to evaluate, you're essentially creating a new instance of that, which is another 4 gigs of RAM being allocated just to be able to cross-compile that. There is another way of doing cross-compilation, which is emulated, but that is not real cross-compilation, and there's a lot of issues with that. So pretty much the plan is to streamline how we handle cross-compilation right now in Nix packages. So part of that plan is to redo how the C compiler is introduced in or loaded in Nix packages. Currently there is a CC attribute which contains the C compiler, which is essentially the entire toolchain for C. Inside the standard environment, there is a SCM no libc function, or no CC set, which is the SCM without a C compiler. So the idea is to make that essentially the default, and for more packages to use that by default without a C compiler, and instead explicitly inheriting a C compiler without implicitly having one. And one of the things we're doing is also adding new toolchain attributes. So this is part of the splitting of the tool of GCC. So now it's all going to be in their own components. And kind of why cross-compiling is important. If you want to target like an AVR, you can't really compile your code on an AVR device, or you can't compile on an ESP32. You have to have a toolchain which can cross-compile from your host system to the target system. It's also useful for finding bugs in builds without having the actual hardware. So like if you want to support RISC-V but you just don't have any hardware for it, you then can use a cross-compilation build, and then you can also integrate that with QEMU and NixOS VMs and have an automated test suite essentially to be able to build and test for any device that you don't really have. And there's two kinds of methodologies into cross-compilation in Nix packages. There is packages across, which gives you a set of various platforms like targeting PowerPC, x86, 32-bit and 64-bit, RISC-V, 32-bit, 64-bit, all that. They create a new Nix packages instance, which we call a variant now. It's pretty simple to use, but it's harder to chain up. Like let's say if you want to do a statically linked LOVM build for RISC-V, you can't really chain that. A lot of the attributes just collide and you lose a lot of that inheriting that's going on. You can do this by manually importing Nix packages and specifying the attributes, but that is not really recommended currently in Nix packages. There is the override way. Essentially, the SEM is an attribute that everyone pulls in to create a package, and that's actually powerful because if you use an override, you overlay onto a package, you can actually override that package and then have a new standard environment. This will change how we have disjoining CC and SEM, but essentially it is the same principle going on. And the new way of doing cross we have being worked on is called cross SEM. It is a chainable attribute set. And so as you can tell by the example, we're able to define a cross-compiling standard environment for ARM that is statically linked. And so that's a lot of a more streamlined way of doing it rather than being able to create a new Nix packages instance. And the idea is to also do one stage of bootstrapping. So with cross-compiling currently, it goes through like 3 to 4 stages where it builds from like your host to target, then build to target. It does this weird set of chaining that takes a lot of resources, a lot of disk space, increases your closure size. The new way is to be cross-compiling as minimal as possible. So essentially, if you only need to have this specific library for that architecture or whatever you're targeting, it's only going to be building that. So it's easier to kind of manipulate and mutate. It's also explicit cross versus implicit. So a lot of with doing packages cross, it kind of depends on what you put into the native build inputs or build inputs, but being able to just override and specify that you want this specific package that's a dependency for the package you're cross-compiling, and just have that one compiled instead rather than having it implicitly done is pretty powerful. And then this is going to work a lot better with multi-target compilers. So this will make it easier to essentially compile your compiler once and then just target any platform. And there's a PR for it right now that's been slow to work on. And then there's something called GCCNG. John Erickson and I, we've been working on this for about 2 months now. It is a very LOVM-brained way of doing GCC, where everything's on their own components. We actually splice it better, so we're able to handle cross-compiling a lot better. There's also this version of GCC is also easier to work with vendor forks, because some vendors like TenStorrent or Expressive like to fork and change GCC and different compilers around, and being able to just point GCC-ng to whatever that source is, and then just tell it to compile, and then just get the compiler is a lot easier to work with than trying to manually do it or do some weird overrides that we currently have, or weirdly importing it in a way. There's just actually a function called build GCC package set, which spits out an entire GCC package set for whatever version of GCC you want. And then LLVM's kind of getting the same sort of treatment, where I've been for pretty much a year now refactoring a lot of how LLVM works to make it work better with splicing and overrides, and being able to be a lot more flexible and easier to work with, but more maintainable. And so the entire idea is just to streamline how we're doing toolchains. And I actually do have a bit of a demo of how we can do this currently. So as you can tell, these are three different kind of ways of doing cross-compiling. So this is the packages cross method. You then have the override method, which you can see we just specify packages cross and pull in the standard environment. And then this is the sort of new way of doing it with the cross SDN, where as you can tell, we are doing cross-compiling for 32-bit ARM. I'm doing it with hello. And then if I give it a start, you can see it's just evaluated everything, and now it's actually cross-compiling all those. And there's actually a lot of logic of how this works currently, but with a lot of the new work, this will be very streamlined once we have a more override-friendly way of doing cross-compiling and manipulating tool chains. Any questions? No, but so we can't really use it with the badges because the Expressive IDF, which is their SDK, is very strict with how it wants to be used. You technically could, but it's just we haven't had the time to actually do that, and just there isn't the infrastructure in Nix packages right now. But it technically is possible. Explaining splicing, so essentially the idea is that a lot of how Nix packages works is it happens in a series of kind of like, you can imagine everything as an overlay in Nix packages. And let's say if you want to override something, you have to splice it. Essentially that means you kind of cut it out at that point and inject something new. And so we do this a lot with the three different build platforms. So this is actually like a kind of like way of how things are done with compilers, where you have build, host, and target, and those defines like how things are pointed to and what supports what. So like host is the system you're actually like kind of natively running on, but the build is what you're actually building on, and then target is whatever the devices you're targeting. And so we have actually three attribute sets which mimic that behavior. We have build packages, host packages, and target packages. And splicing changes based on like what phase of Nix packages you're in. And so using that I forget the name, but so that make function that handles splicing a lot better. Yeah, that essentially controls how the attribute set is defined with overrides. There's a lot of logic in actual Nix packages of how to handle the splicing correctly. Any other questions? I don't see it impacting flakes currently, but I could see it in the future being a sort of stepping stone to improving cross compilation. I have floated some ideas with trying to think his name. It's Rob, the other Rob, but he's on. I forget the last name, but he's on the Nix team, and we've had some discussions because one of the things I brought up was adding a definition that changes, that kind of pulls in more information about your host into flakes, and so there's been some discussions about that a few months ago. But this could definitely be some sort of thing to look at improving Nix itself to be able to make flakes handle cross compilation better. All right.